So in the previous video, I talked about setting up functions and relations and what they might look like in real life. Now we're going to translate this to the coordinate plane and then talk about, well, what are the implications with domains and ranges and functions and relations as it appears in the coordinate plane. So I'm going to create this little coordinate plane here. Just assume that everything's at a 90-degree angle, life is good, it's wonderful. Just as a quick reminder, this is the y-axis, this is the x-axis, and we're headed positive on the right and positive on the up, so the opposites are negative. Okay, so now I have maybe a set of points. So like this point here, we'll call this B, we'll call that A, we'll call this C, point here, and then here is a point D. And then I'll give these some values so that we all know what we're talking about here. Point A may have a value of something like -5, 5. Point B might be something like -2, 2. C may be -3, -4. And then D may be -2, -6. And then we'll discuss what the domain and range is, and then ask ourselves, is it in fact a function? So the domain are all possible x values. So the domain, all possible x's. The range, whoa, let's have value, good job, we did it. Good job spelling. And then the range is all possible y's. Now, I'm not doing this, and some people might view this and be like, oh, you're not writing it in proper mathematical notation. You're right, because most people don't understand it, and I can't tell you that I remember all the words myself. So all possible y values. It's a very condensed language. If you've ever read math language, it's terrible. So the domains, we list all of the x values. So we can say that the domain of this thing, whatever it happens to be, is equal to the set in no particular order, because sets do not need orders necessarily. -2. Now we have -2 occurring twice. We only need to list it once. And -3. So -5, -2, -3, and -2. Yes, we have all of those possible x values. The range, and R and G sometimes is what people do, but that gets confused with random number generators, so it's kind of weird. The range are the list of all of the y values. And again, they don't need to be in any particular order. So I'm traveling through the A, B, C's, D's. So 5 to -4, -6. 5 to -4, -6. And those are the sets. So this is either a relation or more specifically a function. It's possible. So we have to analyze it to figure out which one is it. It's at least a relation. Is it possibly a function as well? Well, sometimes it's actually easier to ask yourself, is it not a function? And so we would need a definition. So close your eyes or bear with me here. We're going to go zoom up. So the definition of a relation is a correspondence from a set A to a set B, such that there's at least one element A from the domain corresponding to each element of the domain corresponds to at least one element of the range. So each x has at least one y associated with it. A function says that each x has exactly one y associated with it. So let's go see if any of that is violated down here. So a relation, -5 is related to 5. Yeah, all right. -2 corresponds to 2. Sure. -3 corresponds to -4. All right. -2 corresponds to -6. Yeah, all right. That's fine. That's kosher. So this is at least a relation. So now let's check for functionality. Remember that each element of the domain, each x, corresponds to exactly one y. So that means that if you have a single x value that has more than one y associated with it, it is not a function. It violates the exactly one part. Take a look at B and D. Both share a common x value, -2, but have different y values. So if that's true, then that means that it's violating that exactly one aspect of the function definition. So this thing, this set of points, represents a relation, but not a function. And remember what caused this is we had two different y values for the same x. It's almost like if you connected the dots, you'd get a vertical line. And we can generalize this and say, okay, well, if a vertical line connects any 2 points on a graph, then those 2 points violate the definition of function. Because of that, we get something called the vertical line test. That vertical line test is just simply a test on a function, on the definition of function. So if you take a vertical line and you sweep it through your graph and it touches it more than once at any part, it's not a function. The problem is you got to sweep through the entire domain. And so typically what will happen is, in the beginning at least, instructors and teachers will give you functions that behave erratically in a small area, rather than, oh, there's a weirdness that happens way the hell out and gone over yonder. You don't see it, but it happens. Well, they're not going to concentrate on that immediately. That's later on down the line. Okay. In the next video, I'm just going to give you a list of, here's some examples, and are they functions or are they relations?